In this lecture, we'll learn about the manipulation of strings, but the main motivation of this lecture is for us to really understand how pointers work in C. We're going to see how the access of memory through pointers is translated into instructions in RISC-V. The main motivation for this lecture is to understand pointer manipulation and understand how naturally sometimes in a C program it is we create data types such as char, star, star, star. We'll start with the notion of strings, and I'm going to record this lecture in 3 parts to make it easier for you to watch. We start with the notion of a string. A string is a sequence of characters that is terminated by a null character, that's the character 0. So let's say that I have not one string, but I have several strings that I wanted to store in memory. And these strings are the names of students in 229 2 years ago, in the fall of 2018. And for example, Veronica, after finishing 229 and after finishing 415, I arranged an internship for her at Huawei in Marcan, where she did very well. She's back into the program now after her internship for her last year in the program. She was very successful working in programming languages at Huawei. Taylor was also a 229 student. Taylor is actually the student that has created the transformation of the slides that you're seeing right now from MIPS into RISC-V. It happened in the summer of 2019. And after that, Taylor went into an internship, his work at the local office of Huawei in Edmonton, working with software to support learning systems. In order to store these strings in memory, I'm going to need some memory. So here, let's build some memory. And each character of a string is a single byte. I'm going to store these strings in memory one after the other. So I have the name of Veronica with the null termination. Next, I have Shinman, and then I have Malcolm, and so on. So all my strings, all my name of students will simply be stored in memory sequentially like this. And here's a quiz that could be a quiz in one of your assessments. I could ask you to write RISC-V assembly code for the function string length, which is a function that receives as a parameter the address of a null terminated string and return the number of characters in the string. So here is a C implementation for this function. The parameter for the function is a pointer to a character S. And the way I'll implement this function, I'll make a copy of the address that is in S into another pointer that I call temp. And then I'm going to first ask whether S is pointing to a null character. So I'll read the memory that contains the character that S is pointing to and ask whether that character is the character 0. If it's not, I'll simply increment the value of pointer and go back and read again. In C, when we have a loop statement like this that contains a single statement, you don't need the brackets. And in the end, I'm going to return the difference between the address of the null character that I found and the initial address of the string, and that will give the length of the string. So if I transform this into an intermediate format code, I'll make a copy of the address that was in A0 into T0. And then I'll go into the memory position given by that address. I'll read the byte that's in there, and I'll put that byte into T1. And then I'm going to ask if that byte is equal 0. If it is equal 0, I'm ready, I can go to the end. Otherwise, I'll increment the value of the pointer by 1, because remember, I'm accessing characters. Each character occupies a single byte. And then I'll go to the next character. And if I get to the end, I subtract the value of the temp, that is the initial address that I had saved, from the address that I got to where I found the character 0. So translating this into assembly for RISC-V, I first make a copy from A0 into T0. It's my temporary. I use a load byte unsigned to get the byte from the address given in A0. And I use in load byte unsigned so that my code will work also when I have extended set of characters. All the characters in the ASCII code have the bit 7 equals 0. So it makes no difference for the ASCII code if you are doing a load byte or a load byte unsigned. But if you happen to work with extended character set, the load byte will sign extended the byte and could put a bunch of ones in the upper 24 bits of your register. So to avoid that and to avoid problems with some other computations characters, it's good to get used to use LBU to load a byte when you are interested on looking at the byte as a character. Next, I'm going to test to see if the character that I just got is the 0 character. If it is, I go to the end. Otherwise, I will increment the pointer by 1. And I'll go back to the next character. In the end, I'm going to subtract the two values. And then I will go to return from my function. This is my end label. This is my next character label. And notice that and I needed to have the name of my function on the top, so that's the label that defines my function. And notice that this function does not use any S registers and does not call any other function. So there is no need to save and restore registers in this function. This is what we call a leaf procedure. So let's see how this function, this code is going to work. Let's say that I pass the address 0x10010019 to my string length. So that's the address of the character H in Haotian's name. And now I'm going to execute the code. I start by initializing T0 by make a copy of that address into T0. And next, I will load the byte from that address. So I load in the H into T1. So the hexadecimal code for the capital H is 0x48. And I 0 extended that to 32 bits. Next, I ask whether the value that's in T1 is equal to 0. It's not. Therefore, I'm going to add 1 to A0. And this will move the pointer into the next character, that's character A. And I'm going to go back and I'm going to read the character and I'll keep doing that. So I accelerate my simulation now. I keep doing that until I get to the point where A0 contains the address 10001A. And in that position, I roll 0, the value is 0. So I test, the value is 0. So I go to the end and I return the difference between A0 and T0. So that will return the value 7. That's the number of characters in the name of Haotian. So this is how the string length works. And this concludes the first part of this recording.